This is Richard with JR PROPO, D-Force Aviation, and this is the fifth in a series of videos designed to help the viewer program their Elite or Matrix transmitter for electric flybarless helicopter use. As always, safety is a primary concern. The programming of the radio is to be done with only the transmitter on. The model should not be powered up and the motor should not be connected. This video will include setting up the throttle curves and setting up the pitch curves. Now, I touched on this in an earlier video. There's a lot of controversy these days regarding whether or not you should have a normal throttle curve in normal mode. A normal curve being defined as a curve that starts at zero throttle. Back in the mid-1970s, when I learned, it was rare to find a radio with special helicopter functions, so there were no idle upper stunt throttle curves. Even when those radios became more common starting in the early 80s, you still had to have a normal mode in order to ramp the throttle up to flying RPM. There were no electric helicopters in the market, and there was only one governor, the Tactron. I only ever saw one Tactron in operation in all those years. When electric helicopters started to become the norm, there was still no soft start and still no governors. So like their early glow counterparts, the power had to be rolled on from a normal throttle curve that started with a zero throttle setting. These days, with good governors available in both ESCs and flybarless units, and ESCs equipped with good soft starts, there really isn't an actual need to have a traditional normal throttle curve. The current wisdom seems to be to have all flight modes set up for governed constant RPM. The thinking here being that it will avoid the issue of taking off, accidentally forgetting to change flight modes from normal to idle up, flipping inverted, and having the power die causing the helicopter to crash. In this type of setup, throttle hold or throttle cut is used to stop the motor and prevent it from starting. In this video, I will show how to set up a normal throttle curve that starts at zero throttle. But if you prefer, you can set the throttle curve in the normal flight mode to be a flat, linear throttle curve, just like we're going to show for Stunt 1 and Stunt 2. Now, for our normal throttle curve, we're assuming that you are using an ESC that uses the actual throttle level from the transmitter in govern mode. That is, when the ESC has been properly calibrated, a 50% throttle setting for the transmitter will result in a 50% governed throttle setting from the ESC. This is how the hobby wing governors work. If you're using an ESC, which uses pre-programmed RPM settings programmed into the ESC with either a programmer or through a computer, and uses the flat curves not as RPM levels, but as bands for an RPM switching function, please refer to the ESC manufacturer's instructions. Note that some of these do not allow a normal throttle curve with a starting point of 0% throttle. Okay, from the home screen, we're going to touch the menu button. Now we're in the first page of the function menu. We're going to go to the lower right-hand corner where it says throttle curve and touch the button. We see the familiar confirm servo hold screen. We're going to touch yes. Okay, now we're in the throttle curve screen. At the upper left, you'll see normal and then the familiar position indicator. If we flip the flight mode switch, we'll see both of these change to reflect the change in the flight mode switch.
Stunt 1. Stunt 2. Normal.
Okay, the first thing we're going to do is we're going to start adding points to our normal throttle mode. And again, we're going to start with a normal throttle curve with 0, but again, you don't have to do this. Okay, we're going to raise the throttle stick. We're going to look down here where it says input here. We're going to go to 25. Up in the left corner of the graph, it says add. This allows us to add points to our throttle curve. We're going to touch that. Okay. Now in this area of the screen, it says for throttle point 1, which is where we are here, input 25, output 25. We're going to change this output to 50%. We're going to touch the box that says output in it. And now we're in a new box that allows us to adjust the throttle curve. We're going to bring this up to 50%. Okay. Now we're going to hit the red X to back out. We're going to increase here. We're going to look again at the output till it says 75. Okay. We're going to add a point here as well. Note that the box to the left now says 0.3, where we are right here. Now, these values here don't say exactly 75 this time. They say 74.7, but this is more than close enough for what we're looking for. We're going to touch the output box, and we're going to reduce the value of the output box to 50%. We do this by clicking the arrow buttons. Red X to back out. Now we're going to raise the throttle stick all the way to 100%. This is our point H, or the high point in our throttle curve. We're going to go back to the box to the left, which now says point H in it, and we're going to reduce the output to 50%. We're going to hit the red X to back out. Now, if we look at our throttle curve, we can see there's a very sharp knee at 0.1, and then it levels off. We'd really like to round that off. At the bottom of the screen on the left, it says EXP. Now, this isn't really for exponential. This is not like putting expo on, say, aileron or elevator. What this will do for us is smooth out that curve. So we go to the box to the right of EXP, where it says inhibit, and touch it. Now we have a new window that says inhibit or activate. We're going to activate EXP. Now we have a nice smooth curve that takes us from 0 to the steady 50%. Now we're going to flip the flight mode switch to stunt 1.
Stunt 1.
Okay. The default is a linear 0, 50, 100% curve. We're going to reduce the throttle stick to 0. We're going to go to the box which says point L in the upper left, and the output, we're going to increase this to 50%. Okay. Halfway through our stick throw, point 1 is already 50%, so we don't have to adjust that, but we do need to adjust point H, the high point. So in moving our throttle stick all the way up, this box is now changed to point H. We're going to touch the output box again, and this time we're going to reduce the output from 100 to 50. Touch the red X to back out. Now, we didn't touch the EXP function here because it won't actually help us any. We already have a flat curve, so there's nothing to smooth out here. Okay, we're going to repeat this for stunt 2. So we're going to flip our idle up switch into stunt 2 position.
Stunt 2.
You saw it change here. Reduce our throttle stick to the L, the lowest position, and we're going to increase this to 50%. Red X to back out. Move the stick to 100%. We're now at point H, it says point H here. We're going to touch the output box again, and we're going to reduce this to 50%. So we have two flat 50% curves. You're going to touch the red X to back out. Again, the throttle curves for stunt 1 and stunt 2 by default are 3-position curves. We can leave it as a 3-position curve, but we're going to make some changes to this in a later video to make it easier to adjust the curves. The next thing we're going to do is look at setting up pitch curves. We're going to reduce our throttle back to low. We're going to flip our flight mode switch back to normal.
Normal.
This to prevent any alarms or any alarm screens from coming on. We're going to press the back button on the face of the transmitter. And we're back on the first page of our function menu. We're going to touch the arrow at the extreme right of the screen. We're now in the second page of the function menu. The upper left is the pitch curve button. We're going to touch that. Again, the confirm servo hold window, we're going to touch yes. We're now on the pitch curve screen, and notice this is identical to the throttle curve screen. Everything in here behaves exactly as it did in the throttle curve screen. Now, all of the curves at default are 0, 50, 100 linear curves.
Stunt 1.
You can see there's no changes as I flip the flight mode switch.
Stunt 2.
Now let's go back to normal for just a minute.
Normal.
Some people like to have all three pitch curves match. I'm one of those people. The pitch in my helicopters is usually somewhere from -11, -12 to +12. And I have this for all three flight modes, and I take off and land with -11 degrees of pitch available to me. And I'm just used to doing this over the years. But a lot of people, especially when they're learning or even later on in their normal mode, don't want to have full negative pitch. They want to adjust things so that they have maybe enough pitch to stick the helicopter down on the pad and not have the wind blow it off, but not enough that it's enough to accidentally slam the helicopter onto the pad. And again, this would be for normal mode only. So one of the things that we can do is to reduce the amount of negative pitch at the bottom end of the pitch curve. So we go back to the box on the left. This is point L. This is our lowest point in the curve, and we touch the output button. Now, we've seen this small window or box before. This allows us to adjust the bottom of the curve. So if we want to reduce the amount of negative pitch, we can start increasing the bottom point. We can do this 1 point at a time. We can do it 10 points at a time. And one of the nice things is on the bench with the motor disabled, we can put a pitch gauge in the helicopter and we can adjust this level to get about -3 degrees of pitch. For purposes of this discussion, let's say that this setting gives us -3 degrees of pitch. I'm going to touch the red X to back out. And let's look at our pitch curve. Notice there's a sharp angle here. We don't really want that. We want the collective pitch function to behave in a smooth fashion. Down here again, we have EXP, and it is inhibited. We're going to touch this. Small window again appears, inhibit or activate. We're going to activate it. And now we have a nice, smooth pitch curve. So as we roll our pitch on, there's not going to be a sharp jerk or knee in the curve, and it'll come on very smoothly. Now, again, we've done this only for normal mode. So if we go into stunt 1,
Stunt 1.
we have our 0, 50, 100 pitch curve, and the same is true of
Stunt 2.
So we've only adjusted the pitch setting in normal mode. Now, one thing I should point out, and this goes along with the discussion earlier about having a normal mode with a throttle curve that starts at 0, and the question of flipping the helicopter inverted and forgetting to flip the switch. Changing your normal curve like this can be just as problematic, because if you flip over the helicopter with only 3 degrees of negative pitch, you're probably going to have the same problem as flipping over and having the throttle go to 0. So you need to really think about which way you want to approach this. Now, one thing to note is that while the collective curve can be changed or trimmed by the user to reduce the negative pitch at the bottom of the curve, we've not changed it at the point at which the helicopter hovers. In the next video, we're going to talk about setting the gyro gains in the various flight modes from the GyroSense menu, and setting the timer, mapping it to a switch, and mapping timer reset to a switch. Thank you.